Hello everyone and welcome back to Arctic Retro. It's the 1st of March here and yeah, this is Norway. We have an incredible amount of snow now. Here you can see some pictures. Me and my son had to clean off our balcony just because I was afraid it would fall down. So I had 2 weeks vacation now and I have been to Hong Kong amongst other things, visiting my fiancée, and that was great. I didn't really plan or had any videos ready for after my vacation. And I really haven't had the time to start something new, but I got a lot of stuff from AliExpress. Among other things, a couple of electronic kits that I have to build. So I thought I'll start my after vacation video with taking a look at that and build those things. It might be interesting. It's not retro computer related, but interesting anyway, I hope. I had a little shopping spree on AliExpress just before I had my vacation, and yeah, it arrived and I simply don't remember what it all is. So I'm gonna go through it one by one and build up the things that needs to be built. It's all electronics related, I think. So let's start with this one. They all came in the same bag, but I already opened it. What does it say? It says here One Piece Science Magic Prism Cube. Well, that's not electronics related, but I thought it looked interesting anyway. So a prism, isn't a prism supposed to be triangle? No, maybe not. Well, there it is. It's simply a piece of glass and you can shine light through it. But it looked cool on the ad. Let's see now. Yeah, for sure it changes colors, but yeah, now it's purple. Just some piece of junk that I didn't need, but I thought was fancy. Yeah, I think this is some kind of alien technology. The next one, this one. What's this then? It's a 5V blue, red, green LED hourglass do-it-yourself kit, adjustable, blah blah blah, AA PCB board, funny electronics, soldering, training. Yeah, so this is something we can build. Let's start with that now. I actually love these kits where you can build some cool gadgets, preferably for use with the old retro computers. Oh, yeah, well, seems to have gotten a little bit shipping damage. There's a couple of chips and bent legs. But I don't think that's really a big problem. We can just bend them back. So there's more chips, a bunch of resistors. I think you could select the color. I selected the blue LEDs. Yeah, this is what I got. No instructions or anything. I need to take a look at the product page now just to see what I bought. So there's 32 LEDs, a bunch of resistors, a little capacitor and another capacitor, and this, I don't know, I think it's a crystal potentiometer, a small switch, some pin headers, 3 chips, they're all marked CD40 something, so that's CMOS, and some connectors. And here it is, it's a 5V hourglass do-it-yourself kit, digital hourglass. and it costs 40 NOK, that's around 4 euros. They're sneaky at AliExpress because they have all these offers, and yeah, in order to get free shipping you have to buy for a certain amount, and in order to get a bundle discount you need to buy like 3 products, stuff like that, and I always fall for it. But it doesn't show how it's gonna look when it's built. Yeah, up here, there it is. So it's just the two PCBs are coupled together. Yeah, here it is. Power input you need to provide. AA corresponds to that, BB corresponds to that. So on one of the PCBs here, this one, we solder in a bunch of resistors, the crystal or what it is, and the 3 chips. And then on the other side, yeah, here's the description. On the other PCB you have all the LEDs. Yeah, I think this is gonna be a long video if I'm gonna build all this, and I have a few more kits. Anyway, as I understand it, I'm gonna solder this side and then LEDs on this side, and then fuse the two together with the pin headers. I'm not gonna film the whole soldering process. Yeah, how was it again with LEDs? I never remember. The short pin is the negative side, and it should go where it's flat, I guess. But I need to double check that before I start. One way to figure that out is to use a multimeter, and all the LEDs will have the same negative or the ground, so we can check that. Yeah, so that's the negative and that's the positive. They are not common. Yeah, it even says in the instructions I showed you that the short pin should go where the plain side is. This needs to look neat, so I don't want to have any wobbly LEDs or not straight, so that is of course a difficulty. I'm not going to solder them all at the same time. Well, this is kind of retro electronics. It's using old school electronics like the old CMOS chips and the old type of LED and not surface mounted stuff. So if I push this on there and try to just flip it. Wow, yeah, kind of works. No, it didn't. Oh, I was trying to save some time, but I think I just take one by one. Then I can use the blue tack, and it's in place there. Because I don't want to bend these legs, because it gets uglier, and they're kind of thick, and the LED could get skewed anyway. Yeah, I solder one pin and then I check. Yeah, it looks alright. Alright, that was one of 32 LEDs. Yeah, that was it. That didn't go too bad. I think there's only 30 LEDs. I guess they sent 2 spares in case a few of them are not working. Oh, this blue tack, it gets incredibly sticky when it gets hot or warm, but push it and it takes off the remains. So that was the display board, I guess we can call it. I don't think there's anything else on this. Then we have this one, and here's a lot more going on. All those resistors. I hope they're all same value. Yeah, looks like 3.3K everywhere. Oh no, that's 1 meg. Yeah, there's one single resistor there. I guess that's the 1 meg. For the resistors I use this bending tool. It's very handy to bend the legs correctly and evenly. 1 meg goes there. Yep. I like to solder in all the resistors in the same direction so that it looks less OCD provoking. Yeah, that was the last of the resistors. A whole bunch of them. There's one left. Yoo-hoo! I can use that for something else. I think I need to look carefully. Yeah, so the rest of the things here, a couple of capacitors and the chips, I'm gonna solder them straight in. I'm not gonna insert sockets, because if one of those chips are broken or get broken, I'm not gonna replace it anyway. I don't have spares. The 3 chips goes in. Capacitors are in, chips are in. Only this little, what I think is a crystal left, and connectors and the switch and the potmeter, and I'll just solder them in and then I'll be back. Just one thing, this little black component, it isn't marked or anything, I soldered it in. It's marked as SW1 and on the instructions it's labeled scroll switch. So I don't know what it is. It's definitely not a crystal. This wouldn't need a crystal either, I think. Yeah, these connectors, they go on this side. Finally, the pin headers goes in, and I guess it's this way. It says A to A, and there's A there, and there's A there. So, well, how to fit this? Yes. And this switch and the potmeter, it's on this side. Alright, it's finished. And now the 2 parts can be separated in case I need to repair anything. Anyway, let's take a look at the actual circuit here and what are these chips. There's 2 4015 and one 4069. So the CD4015, it's a dual 4-bit static shift register chip, and yeah, as you can see, it has 2 shift registers. It has a 4-stage serial input and parallel output register with independent data clock and reset inputs. And the 4069, that's just a boring, simple inverter. 6 inverters in one chip. And these are CMOS variants. And that means that they can be used with higher voltage than the regular TTL level, 5 volts. It says here wide supply voltage range 3 to 15 volts. So what does it actually do? Well, it's an hourglass, and I guess this simple circuit, it just uses that those capacitors, and then somehow triggers some sort of timing, and the chips are used for counting down and up all these LEDs, and all the resistors are connected to all those LEDs to limit the current. And it takes 5 volt input, and that's there, so you need to hook it up to 5 volt. Power supply and power connection was not supplied with this kit, so I'm just gonna solder in. Well, it doesn't fit. I was thinking about just solder in 2 pin headers. I need to cut them, split them. You can, of course, just simply solder in a couple of wires. But this way I can just use a couple of DuPont connectors or wires like this. And the instructions clearly said do not reverse the polarity of the, the voltage input. Alright, let's test. So now green is plus. I just use my bench power supply. I'm pretty excited now if this works or not. And it draws no current, so it's obviously off. Yeah, I'm gonna hit that switch. Well, it doesn't seem to be correct. I mean, yeah, maybe it is. Maybe it's supposed to be lit. Now all the LEDs are filled, so there's nothing wrong with polarity or anything like that. So now it's probably counting down, and the speed is based on that little trim potentiometer. Yeah, you see now it fades away, but shouldn't it go down to the other side? Let's see now. Does it move down? No. It's kind of strange. Oh, I think we have a little bad connection somewhere. Okay. Yeah, I think it's a little bit bad connection here. I don't know. Seems solid enough. Let me try and adjust that potentiometer, see if it runs faster. Yeah, sure. That's very slow. That's fast. But does it look like yeah, in fact, when you turn it, that's what it is, that little black component. It's a switch, some kind of motion detection switch. You know, see? If I turn it now. But all the LEDs doesn't light up. I think there's a bad connection in, yeah, you see here, if I push it in these connectors here. Wow, that's cool. Oh, didn't detect. Oops. I don't want to short anything here. Oh. Switch jumps out. I shorted something. I don't know. No. It's just a poor quality switch. That's bad. Need to hold it in then. Anyway, that was it for this build. The switch is already broken, but apparently the thing works. And quite fun little gadget if I hold in the switch. And if you tap it, it does some strange things. Yeah, so I think that this goes into my box of useless things I'm never gonna use. Over to the next. Yeah, we have this, and it's the same kind of kit. It's a LED round water lamp production kit, triad sports light parts. Kit, fun soldering components, welding. Yeah, these kits are nice if you wanna practice your soldering. I don't think I'm gonna build this in this video. It's gonna be long enough as it is. I have a bigger project to show you. But first, let's open some other packages, because sometimes I find a tool or anything that I find might be useful. I think this is it. It says 10 4-pieces precision pick and hook set, car auto oil seal O-ring, seal gasket. Yeah, it's just some tools with hooks. So I thought maybe this one can be useful. This with this kind of hook can be useful when pulling out chips or anything like that. I'll link all the products in the description of the video. And this one then, it says soldering practice board. Yeah, that's something completely useless, but can be handy if you want to solder some SMD components and practice that, and that's exactly what this is. So it contains a PCB, which is just some mock-up, you know, with a lot of different components, placements. They're not really connected together in any useful way, I think. I don't know, maybe it's some kind of board that's used for something, but it comes with the necessary components. Yeah, there's a small chip, very small. I don't know what kind of chip it is. Let me see if I can read it. It's a CD4017 and a bunch of small resistors. I don't know what that, yeah, that's LEDs, capacitors, I think some transistors. Oh my goodness, these are small, these are microscopic. And there's some diodes. Maybe it is actually a board that does anything. I don't know, it's in Chinese. But this is if I want to practice some SMD soldering, which I'm not going to do in this video. Maybe I'll show you that sometime later. There's supposed to be 2 chips. I only saw one. And this then, yeah, it's a rotating clock case. Red round water lamp mode. That's a rotating clock case. I have this kit here. It's a DIY watch, LED DIY electronic watch kit, digital tube clock. And what's this then? Well, it's just a simple Raspberry Pi Pico board, RP2040, very useful for a lot of small projects. And this has the USB-C power connector. I didn't buy it for any particular purpose, but yeah, this is used on several retro computer projects, like the Pico SID, or what it's called. Then we have this. It's a 7-pixel game console kit puzzle. Pixel game console, 51 single chip do-it-yourself welding practice parts. So this I'm actually going to build. Yeah, it's called a games console. Let's take a look at the listing. Yeah, here it is. It's like this. Looks quite neat. I'm not sure what kind of processor or what it is, this big chip here, but we'll find out that soon. And it was only 73 NOK, like 7 euros. Well, let's see what this is and how we can build it. So let's see now. At least this comes with some instructions. PCB, we have a case, LED display, and even a USB cable. There's some chip, some 7-segment display. Seems kind of easy enough to build. Very few components. Everything is on that chip, and there's a socket. So what is this chip then? So yeah, it has a lot of numbers. 15F2K60S2 and a lot of other stuff. If that's the date code, this was produced last year, 2528. Yeah, and that is in fact a kind of a simple microcontroller. It says here a large capacity of 2 kilobytes of SRAM, high speed 8 channels, 8051 MCU, super low power consumption, very cheap. Yeah. Let's go through this, learn how to program it. It's only 887 pages long, the datasheet. So I guess it's already pre-programmed, otherwise it would need a ROM or some way to program it. The instructions doesn't mention anything about programming it, so yeah. Anyway, let's jump right into it here and start soldering. Or maybe not so fast. It has some components here inside the socket, so I guess it's better to do those first. Yeah, so it's quite simple. Display up here, the MCU, two big LED displays, some buttons, and yeah, a couple of capacitors, resistors, and USB connector, and here's the box for it, and yeah, I'll actually follow the instructions so I don't do a mistake. And it says to start with a 10K resistor up here. And inside here is the two capacitors, a little electrolyte and a little simple 104 ceramic. Oh, that was kind of fiddly. Yeah, I guess I need to bend them over. Bend over. Then it says to solder in the USB socket. Alright, so I'm going to solder this now, and yeah, I'm not going to show you all. It will take too long time, but if anything interesting arises, I will pop in here. Yeah, the displays, I'm not really sure which way they go, either this way or this way. Let's see now. The instruction says the number faces the direction, the side of the circle dot matrix with characters faces the direction of the keys. Characters, yeah, there's numbers there. All right. There's some protective plastic on top. Oops, oh. Yeah. That's how it goes when you are stressing to be finished. Wow, no stress. I tack two corners on each just to start, and then I can press them down from the other side so they're flush. Yeah. All right, some more soldering. Yes, that was it for the soldering. I'm now gonna test this before I put it in the case. Gonna insert the chip. Hopefully everything works. No, that was not the right way. Always check. Now I can try my new hook tool here. Yeah, works fine. The notch is that way. Well, you can't always beat yourself up for everything, but now it's time to do that. Even though I checked that the number was on the correct side, I managed to install these the wrong way. The number should be against the buttons. I put them the other way around. Yeah. I'm just gonna quickly desolder and turn them around. My brain was apparently not functioning, or it was somehow reversed. But this is fresh solder on a fresh board, so it should be quite easy. Yeah, that went smooth. This way. This way. Good thing I noticed that before I started testing. There's one more thing to solder, and it's the battery terminal leads, because this runs on batteries. Yeah, a little bit of cleaning and we can test this thing. So I guess the battery leads are only necessary when you hook up batteries. It has a USB power input, but this is a very short cable. I'm not sure how I'm supposed to be using this. I have a battery bank here. Let's test, see if this works. Oh. Yeah. No sound. I'll turn off the light so you can see it better. No beepity beep. At least the chip is working. One. On. One. And what is this supposed to be doing? It counts up when you go right, left, 3. But then suddenly it just seems like it resets. Yeah, 1, select, and then it resets. So select, yeah, and then it resets. So I don't think it's working as it's supposed to. And then you see the score turns on and then off. Just gonna check if the chip was properly in. Maybe use a little bit of contact cleaner. Everything looks fine. One, 2, 3, 4, 5, and then it resets. Oh, I think it's the battery, because I see the battery is blinking. Yes, it's because of the battery bank. It's probably discharged. I haven't used it for a couple of years, I think. So, okay. So now let's select Tetris. Now we can play. Yeah. Oh. How to turn? How do I turn them around? That's like pause. You cannot turn the... Oh yeah, the button. But now sound. 0 points. Let me try this. What's this? This one. Oh, some kind of racing game. Oh, you can speed up. Oh, that's setting for the speaker. It's a speaker symbol. It says 1, 0, 1. It was at 1. That's the brightness of the LEDs. So it has 6 games. Speaker is 1. What if we set it to 0? What the heck is this? You can select letters and numbers. Well, I need to figure out why it doesn't make any sounds. You see that little speaker? It has a plus symbol, and I'm pretty sure I put it the correct way. Of course, the labeling is under it, but yeah, I'm gonna desolder it and turn it the other way. See if that helps. Yeah, it's clearly marked plus there, but of course it might be wrong. Try to solder it in that way, or at least I try to hold it in, see if it makes any sound. No, it didn't work the other way around, so I'm going to try just with a simple small speaker like this. I don't know how these piezo electric speakers work, but I think you can use like a normal speaker. At least you can hear something. Yes, of course. Yeah, so I think that little piezo speaker is is not working. This one works, but this one's too big to have in the enclosure. So this little guy is not working. Can it be opened, or can you do anything? I don't think I have such a thing lying around. I have a few of those kits. Yeah, there's one there. Yeah, there's even 2. These are some electronic kits I bought a long time ago. This looks exactly like the one I need. I didn't solder it in yet, just gonna hold it like that. Yeah, yeah, that one works. So just a tiny little repair on my new games console. I would like to use this big speaker. It sounded much better, but yeah, it doesn't fit. Or I didn't really try. Maybe it fits. Yeah, it actually has an enclosure. I mean, speaker. Maybe it fits. Maybe I can use the big one. So now. Yeah. Oh, it's sounding better if you have a... if you cover the hole. I'm gonna do that. Just a little bit of tape. Yeah, I've seen this comes with a tape over. I don't know why, but... Okay, so let me just insert this into the enclosure then. Now, the speaker, it's definitely too big to fit. Even comes with a small screwdriver. So I'm try not to make this dirty on the inside. Yeah. Yeah. That's it. It has some screws. There's a spring. Yeah, that's for the battery terminals. This goes on top. Yeah, we need to insert the battery terminals. I guess they go in from this side then. Plus is the... no, minus is usually the spring. Takes 4 AAA batteries. Just one little solder job, the battery leads. Let me see, plus is there, the red one. So, yeah, and the battery leads, they touch the PCB, so I need to bend them. Yeah, and now those dinky little screws, they go there. Yeah, that works. Ah, the last screw is for the battery compartment. Okay, let me find some batteries, test this thing. There's a big scratch in that lid. It doesn't have a power switch, but I noticed it turned itself off after a little while of inactivity. Spring isn't hard enough, but yeah, it works. Looks kind of cool. The handheld games console from AliExpress is finished. Oh, that doesn't look very nice. Yeah, it's totally playable for Tetris. Oh. I'm unbeatable. There's no way to end the game, you actually just have to leave it. What's this? So now if I want to end this game, I just have to wait. Alrighty, that was that. I'm not sure how long this video is currently now, but I think we can manage one more. What about this watch? LED do-it-yourself electronic watch kit, digital tube clock accessories soldering. Yeah, we need to make one more. This was fun. Where's my knife? I think this is kind of easy build too. It has a chip and 4 7 segments clock display. Some small capacitor, some battery holder, I think. A small PCB. Yeah, it actually is an arm wrist clock. So that's the belt, what you call it in English, for your arm or your wrist. That's a few buttons. Yeah, that's the crystal, definitely. Just take a brief look at the instructions. Yeah, first I thought it was only in Chinese, but the other side it's in English. Start with a resistor R1, then the crystal oscillator at Y1. Yeah, there's only one resistor. And the oscillator polarity doesn't matter. Yeah, I'm gonna wear this, so it needs to look nice. This will be a replacement for my Apple Watch. It has the same features, almost. You know, time and stuff. But perhaps without all the alerts and interruptions from the Apple Watch, this will be better. Then we have a bunch of capacitors. Yeah, it's clearly labeled 104 and 22. 104, it's there. Then we have 222. Like so. Yeah, that was not good soldering. There's one more capacitor. I don't think it's gonna go anywhere. I think it's just one spare. Yeah. Then we have switches. Oh, 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 oh. It quickly heats up. And the second switch. Adjust it. And that was it. Next is the display and the chip. I'm not going to use a socket on this one either, because then it might not fit in the enclosure. So I guess this too is some kind of microcontroller chip. I cannot read the label at all. I tried different angles, but yeah, it's simply not readable. So it's a no-name chip. Kind of long pins on this. Well, it's normal length, but I'm used to soldering in chips that has been cut or using sockets, so clean a little bit before it gets too hard. I mean the flux. And then we have the display with extremely long pins. It has this film on it. And I guess the dots go down, but what's up and down here? Chip is up. Yeah, it's on the label there. You can see where the dots go. Yes. Yeah, that was it for the soldering, I think. Yeah, except the battery holder. So what do you think about this kind of video? Should I make more, or was it not fun at all? Tell me in the comments. Just in there. Yeah, one extra capacitor for later use. Oh, it's a 104. There was only one 104. I can't see anything else. Either they can't count in China or they purposely put one extra, but why not one extra of the other components then? Let's test. I think I have a battery here. Sorry, little Christmas guy from PCB Way. I need to take your battery. Well, I saw some numbers, but that was all. Yeah, okay, we obviously need to set the time, maybe. But how? Probably just, yeah, hold it in. Is it 24-hour clock or only 12? Ah, only 12. Unusable for Norway. We use 24-hour clock here, obviously, but maybe you can change that. Anyway, it works. Aha, it says here in the instructions, if you short these two pins, then you keep the watch on all the time, and if you short these two, then you have a 24-hour system. Let's do that. Yeah, 24-hour system, these two, but that's a long way to bridge. I think I need to use a little wire. Yeah, I can just use a little resistor wire here. So now it should be 24 hours, but it takes a while to initialize apparently. Well, now it won't turn on. Yeah, it turned on. It's probably some bad contact, I think, with the battery, I don't know. But now we should be able to get it to more than 12. Yes. So the time here now is about 20. Yeah, you see I push the battery all the way in, it cuts out. Strange. I don't know why, there's a big pad there, but apparently it doesn't make contact. Flush it with some contact cleaner. Nope. You need to have the battery a little bit out. Why? I mean, it is connected. Yeah, if I push it real hard. Maybe if I add a tiny little solder blob in the middle, it will work better. Yes. Yes. And then to keep it on all the time, we need to bridge these 2 points. Yeah, there. Need a little bit extra solder there. Obviously, if you have sensitive electronics, you wouldn't solder it while it's on, but I'm taking my chances here. So, now it's always on. It's much more brighter than it looks on the video now because too much light right down. Let me turn off the lights. I now can see it's flickering, but you don't see the flickering for real. Now the enclosure, and yeah, it has 2 holes here for the switches. Is it gonna go up or down? I think it's, yeah, I think it's this way. but it doesn't go in. Oh, maybe it's this way. Yeah, that's the correct way. That's a perfect fit. And the screw holes go through the PCB with some very, very long thin screws. I mean, it's simple enough, but it's nicely built for that price. And it's all based on old school technology. No FPGA or anything like that. No SMD. Yeah, that's it. Only drawback is that you need to open it up to replace the battery, but guess we can live with that. And now it's supposed to go like this. Yeah, let me try. It's a rubber band, not very far from my Apple Watch. But these are usually just crap. It doesn't hold very well. Yeah, but these seem okay-ish, as long as the plastic holds. Yeah, I think I put, it's obviously gonna go there since I'm left-handed. No, I'm right-handed. That's why I put it on the left. Yeah. The wristband, it feels okay. Good enough quality for Norway. Yeah. But too bad it doesn't have any other features like a stopwatch or something like that. Would be cool. So what do you think about my new watch? And how accurate do you think it is? It's based on a crystal oscillator. Is it accurate enough to keep the time correct? I set it now to 1956, which is exactly what the time is now. I'm gonna check tomorrow, see if it kept it within the minute at least. Yes, that was it for this video. I hope you found it interesting and a little bit fun. I thought it was fun. I have a couple of more kits and a few more coming up. I didn't receive yet, but tell me in the comments if you'd like to see more of this. And the next video, I promise, will be some retro computer related. Yeah, it's now 1958, so the clock is working and ticking. Anyway, that was it for this video. Thanks for watching, and please subscribe and like this video if you like this content. And please consider becoming a Patreon member too if you want to do that. See you. Bye bye.